In this video, I will talk about how to solve or how to find out the current and the potential difference across resistors which are connected in a complicated way. So for example, we have this circuit here. We see there are multiple the source voltage or the applied voltage, and this circuit cannot be solved simply by using the series and parallel combination, or it will be hard sometimes. So in that case, we use the Kirchhoff's law to solve that problem. So first thing, what we're going to do is first you have to find out, choose the direction of the current. Okay, so again, choosing the direction of current is entirely up to you. So here I have chosen this as my current direction, and so as this is a direction of the current, I'm calling this as an I1, and then I'm calling this as an I3, and this as an I2. So and the I2 now follows through this circuit here, I2. Whatever current flows through this 20 ohm, the same current is flowing through this 5 ohm here. And now this is I3. So I have now chosen the current direction. So after choosing the current direction, again, as I said, you may choose the current direction this way too. Your answer will be negative, and then you have to interpret the meaning of it. So choosing the current direction is entirely up to you. The second thing you have to do is choose the loop direction. Here I have two loops. This is one loop and this is another loop here. So first thing you have to do now, again, choose the loop direction. Again, choosing the loop direction is entirely up to you again. So here I have chosen the counterclockwise as my loop. Here also I have chosen the counterclockwise. You may choose whatever direction you like to. After doing that one, assume this is I1, this is I3, and this is I2. Okay, and then as this is I2, the same current flows through this one, and I3 will be in this path. So let's apply the junction rule now, and we're going to apply the junction rule at this point A. Okay, at this point A, what the junction rule is, the incoming current is equal to the outgoing current. At this junction, what are the incoming current? The incoming current is I1, and outgoing currents are I2 and I3. So by Kirchhoff's first rule, this has to be equal to, I1 has to be equal to I2 plus I3, because this is incoming and these are outgoing. So incoming current has to be equal to the outgoing current. So that's my rule 1. Now let's apply the voltage rule in this loop here. Okay, so let's start with this one here. For this circuit here, this is my current direction, and here is my loop direction. You see, so this is coming this way. So this is my current direction. If I have to look at this point here, so the loop direction is opposite. The current and the loop direction are opposite. If that is opposite, then the potential difference across this resistor is positive. And what is the potential difference across this one? This is equal to I current times 10, because this is the 10 ohm resistor. 10 times I1, or I1 times R1, and R1 is 10. So this is equal to 10 times I1, and this is positive. Okay, so now let's look at this resistor here. Here the current is downward and the loop direction is upward. Both are again opposite. That means if they are opposite, you have to consider as a positive. And this is 50 ohm and the current is I3. So simply writing 15 times I3. And now we have one more components. In this case, the here the loop direction is from positive to negative. If it is going from positive to negative, then we consider this as a negative. So that's the negative here. So and by Kirchhoff's of rule 1, the rule 2 or loop rule, this has to be equal to 0. Now let's do exactly the same thing in loop 2 here. Let's apply the Kirchhoff's voltage rule. So let's start with here at this point here. The current is in this direction and the loop is in this direction. Let's say this is the loop here. The current and the loop are in opposite direction. If they are opposite direction, what does that mean? That means the voltage has to be positive. How do we find out the voltage here? The resistance times the current, that gives you the voltage. So 20 times I2. So here 20 times I2. So this is done. Now let's choose this one now. Here the current and the loop are in the same direction. So this is the current direction and this is the loop direction. Both are parallel. If they are parallel, you consider as a negative. So that's the negative. And the value should be 15 times I3. So 15 times I3. Okay. And now for this component here. For this component, the current is in this direction. So the loop is in this direction and the current is in opposite direction. That means it has to be positive. So how do we write down? 5 times I2. So here it is 5 times I2. This is equal. And now for the battery it is going from negative to positive. If it is going from negative to positive, we take this as a positive voltage, which is 15 volt. So this is the 15 here. Okay, so we have 2 I2 here, 20 plus 5. I'm adding them together. That gives you 25 I2 minus 15 I3 plus 15. This equals to 0. So we have now 3 equations, 1, 2, and 3. And the rest is the math. Once you have written down all these equations, the physics part is done. The next thing is just the math part. You have to solve it. Okay, so we have 3 unknown variables, I1, I2, and I3, and we have 3 equations, so it can be solved. So first thing we're going to do, we're going to plug equation 1 into equation 2. So we're going to plug, so instead of I1, now we'll write down I2 plus I3. So let's do here 10 times I2 plus I3. So here 10, instead of I1, I'm going to write down I2 plus I3. I2 plus I3. And the rest will be the same thing. 15 I3 minus 10 equals to 0. If I multiply them together, it will be 10 I2 plus 10 I3 plus 15 I3 minus 10. This 10 I3 plus 15 I3 will be 25 I3. That is here. So now I can use, so if you look at this equation, equation 3 and equation 4, I have only I2 and I3 as my variable. So if you have a calculator, you should be able to solve simultaneous equations. Okay, so if you solve using the equations, then that will give you the value of I2 and I3. Once you know I2 and I3, then you can find out I1 by plugging into this equation. Plugging into this equation, I1 should be I2 plus I3. So I have this I2 and I3, and then plug in, and I will get this current here, 7 over 31. The one last thing I would like to mention here, I2 is negative. Okay, I2 is negative. What does this mean here? Why did I get negative current? The I2 here, I have chosen this direction as, this is my direction here, but I2 negative means that in fact the current here should be following in this direction. That's what it means. Instead of current going in this direction, the current in reality has to be in this direction. That's what the negative sign tells you. So again, choose whatever direction you like to. If you get negative, that means the direction has to be opposite direction. Okay, that's the meaning of it. So, and again, you can solve exactly the same problem using a simulation, and I'm going to show here quickly. So here I have set up the simulation here, 10 ohm, 20 ohm, 15, and now let's find out the voltage across. So what we have current here is, the current in this case is I2 is 9 over 31 and 16 over 32. I3 is 16 over 32, which is close to 0.5. So let's find it out. So you can simply drag this ammeter and measure the current, whatever you like. So this is 0.29, this is 0.25, this is 0.5. So you see this is close to 0.5. Okay, so you should be able to find out the current anywhere you like. If you solve it, 7 over 31, you will get this value here. Okay, and see here the direction of the current in fact is going from this way. So using this simulation, you should be able to double check your answer. So this is it from this video. If you have any questions, write down your questions in the comment section below, and do not forget to like, share and subscribe the channel. Thank you very much.